Rick Stratton is a fire analyst for the Washington office, Planning and Budget. His wildland fire interests include geospatial fire modeling, long-term assessment, fuel treatment design and effectiveness, risk assessment, resource allocation, and wildland-urban interface home ignitability assessments and destruction investigations. Prior to his current position, Rick served 7 years at the Forest Service Regional Office, DLM State Office in Portland, Oregon, and 10 years as a consultant at the Fire Sciences Lab in Missoula, Montana, for Systems for Environmental Management. Rick will present about the use of FS Pro and quantitative wildfire risk assessments to create exceedance probability curves to aid incident prioritization. Welcome, Rick.
So I'm going to talk about EP curves to help inform wildfire prioritization. Before I begin, I do want to express special thanks to Brian Mayer and Jim Edmonds. Brian is a sub-regional planner on the Okanagan-Wenatchee in Washington, and Jim Edmonds is a programmer for the State Office Regional Office in Portland, and both of them helped with the programming of developing the exceedance probability curves during the fire season. So EP curves have been used by Matt Thompson and Joe Scott in the past on a couple papers, particularly in 2015, that deal with risk assessment in the risk assessment literature. Instead of output from the large fire simulator, which is from Mark Finney, called FSIM, we used information from FS Pro runs and then combined it with a quantitative wildfire risk assessment. I'll talk about the risk assessment in a second and then show you some of the FS Pro work. From the risk assessment, we obtain location, inventory of values that warrant protection. We call those highly valued resources and assets, HVRAs, and their response to fire. FS Pro tells us what is the probability of the fire reaching the HVRAs given that specific time, in this case 7, 10, or 14 days. The product of these two outputs, the EP curves, can be used by local unit, area commands, GACs, MACs, state, or regional to help inform execs and for prioritization. So wanted a quick slide on science and modeling technology. You know, why do we want to use this in fire management? Our earlier presenter mentioned about the resistance sometimes to these kinds of things in fire management. I've found over the years, you know, it can help us identify areas of concern pre-season and facilitate planning and to mitigate that threat. It promotes these pre-season dialogues, if they be fire simulations or reviews and outreach. It also helps the user to think strategically and to see fires in the appropriate scale as a landscape occurrence. It also helps us to visualize the scope of the problem and the impact to the broader landscape and audience. They also help us to perform multiple scenarios to gain the landscape, which we can't do in practice. Helps us to validate our inherent suppositions, helps us answer and form new questions. The information can be informative and can be used for documentation. And then lastly, it's per our policy and direction, and that's what this slide is about. So that statement we see a lot, sound risk management is the foundation for all fire management activities. That's from the 1995 program review, but it's also echoed in the 2009 guidance, the cohesive strategy, and you'll find elements of this in policy manuals like the Forest Service and the BLM. But this isn't just policy or documents that have happened in the past. Just recently, as this year and last year, we see this kind of we see this being brought to our attention that we need to continue to use these things in the federal agencies. So the one is from 2017, which was the direction from the Wildland Fire Leadership from the Secretary of Agriculture and Interiors to the 5 federal agencies, which stated we will also continue to integrate science and technology into all our firefighting and to capitalize on other advancements to better inform and support our firefighting capabilities. And then with our new secretary, we have those strategic goals that came out in this. If you saw some of those videos, the strategic goal number 5 was strengthen the stewardship of private lands through technology and research. And then in Chief Took's oath of office address, he said all our actions will continue to be anchored in science and be based on good data. So we definitely, in the past and currently, have the impetus to use this to help inform our management practices. So first, before I talk about the EP curves, I got to tell you about this risk assessment, since part of it is from it. So the Pacific Northwest Quantitative Wildfire Risk Assessment, we're just finishing up. It's been about a 2-year effort. We've gone through a couple of versions, and in a month we'll have the final version out. It's based on Joe Scott's framework and that GTR 315. And we had 3 foundational goals for this all lands risk assessment in Oregon and Washington, and that was all lands, it needs to be an interagency effort. And lastly, once we create a product, we want to immediately use it in the wildland fire management community, as well as federal, state programs, and private industry and public. There's utility there too. So to do this, we did 4 workshops. One, looking at the fuels data, incorporate all the learning, the modeling we've used in the several years past. We looked at the things we care about, those HVRAs. We brought folks together to talk about how do these HVRAs respond to fire. And then lastly, we brought together line officers to talk about how do we rank these HVRAs. So here's that HVRA list. You can see infrastructure, people and property, timber, veg condition, watershed that's specifically focused on intakes, and then wildlife. These were the things that we could map all lands and that were of interest to the groups of folks as we discuss this in our meetings. So this is the risk assessment process to give you a feel for what happens. We first start with those HVRAs. We then assign response functions based on intensity levels, so that FIL1 is flame length from 0 to 2 feet, and 2 is 2 to 4 feet, etc. And the positives, you can have up to 100% positive benefit and to a negative 100 negative benefit. And so each of these things we care about respond positive or negative to fire. And so the response functions are developed for all those HVRAs that I showed previously. Then all this information is brought together for line officers to weigh in and discuss. And again, this is an all lands project. This was not just Forest Service or federal agencies that have state partners and as well as some other individuals. So collectively, we created a relative importance ranking, and you can see what these things are. PP is property and people and places, wildlife, infrastructure, timber, veg condition, and water. That information, then we take that information. We also use SM to create burn probabilities throughout Oregon and Washington. This was done at 120 meter resolution, the finest that has been ever done in such a large land base. And then lastly, we get the products. In this case, this is an example of the true risk map or the expected net value change map. So from the risk assessment, here's the key. We get this conditional net value change. So if a fire does occur at that site, on that pixel, this would be the resultant change, the net change of all those values that were listed previously. So this is the Sisters, Oregon area. There was a Millie fire in 2017 to the southwest, and it displays a single color at that net change for each of those pixels. The green is a positive change, a benefit, and the yellow is 0 to a little less of a change, negative change, and then the reds are a very high loss. And all these colors are aggregated up by those assets and resources over a distribution of flame lengths over tens of thousands of artificial seasons. So we take that information, and then, so that's the risk assessment information, and we put it together with the FS Pro information. Slide, here's the FS Pro runs for 10 days, September 6th through 15th. There's 4 days of forecast and 3,000 fires simulated, and we timed it so the start and end dates are all the same for the 8 different analysts. We modeled about 25 fires simulated. And it includes previous fires and current containment lines and assumes no suppression. So for each of the 3,000 fires, an overall CMVC is calculated for each of the perimeters, and then this operation is repeated for each individual fire, and then the data is graphed. So here's what you came for. This is one of the EP curves. And I'll call your attention, first of all, at the height of the fire season of 2017, the MAC group wanted to focus on assets and timber only. So on the left is a negative response to fire. On the right is the positive, because assets, almost all assets, respond negatively to fire. The net of what we did was a loss. So the way to read this is, on the left is the loss, on the right is the positive response. And if you look at the key up here, a low net loss is 0 to -5, a moderate -5 to -10, a high -10 to -20, and then very high is the -20 plus. And so what we're looking at here is each of those lines are fires. So the red is Chetco Bar, the dashed light blue is Norris Peak, and that light blue is Eagle Creek. And then the dark black line's Jolly. You know, those were very large, very prominent fires at the time. And so what we could learn from this is, in the next 10 days, if you go up here to the asterisk at the top, right out of the gate, in the next 10 days, as the fires grow based on the FS Pro runs, their response would be a loss, so a mild to moderate loss. But you can see as Chetco Bar continues to grow and gets into those outer bounds of FS Pro runs, the loss is substantially higher than the other fires. You know, in the order, you know, it quadruples to some of those other fires, and some of the really small fires near the zero line, it's on magnitude of, you know, 10, 15 times more. I'm gonna show you a graph that's scaled a little differently. This is scaled to 10 versus the other one was scaled to 40, and you can start seeing the difference between the different fires. So a lot of the fires are really near that zero line, which means in the next 10 days, it's not likely that they are really going to incur a significant loss if it comes to assets or timber. But there was one that's a little different than the others, and that's the dashed green one. So the Umpqua North Complex kind of separates itself from all the other fires. That it appears that in the next 10 days, that some assets and timber losses could be realized. So that would be like a low to moderate loss. And then there's those others that are much higher losses. So this information can be one of many things that can help inform the prioritization. So when I presented this to the Northwest MAC, you know, this is what the science and the modeling would suggest in the next 10 days would be the priority list. And then I have it outlined here with Chetco at the top, and then some of those others, you know, Blanket and High Cascade Complex at the bottom. So I wanted to give you a couple other quick examples. This one is earlier, August 28th to the 3rd. It's 7 days instead of 10. 3 days of forecast, 3,000 fires, and about 8 analysts. So this one, there was a fire called Horse Prairie that was more on state lands. They're very concerned about the WUI and concerned about timber values there, as well as there's some teeny wildlife habitat. And so you can see when it's scaled like this, that fire clearly separates itself from the other fires. If you look back in the screen, you can see Horse Prairie's the FS Pro run down in the southwest. And then in the middle, there's two others. That would be Ragged and Happy Dog Twin. That's the dashed red, and then the dashed blue is Rebel Horse Creek. So those ones are maybe like half the loss of Horse Creek, and then twice the loss or 3 times the loss of some of these others. If we scale it a little differently at 10, then you can start seeing some of the fires that have a positive benefit. So this, instead of assets and timber, this was all the values that I showed earlier. So this takes into account the positive benefits of fire, like the veg condition. So there are 2 on the right in this case, and those would be Spruce Lake, and the other one is Blanket Creek. And these were at higher elevations, and they were, one was in and out of the park, Crater Lake, as well as in the wilderness areas, and they were showing in the next 7 days that there was a benefit for fire, particularly based on vegetation condition, where then you can see the separation of some of the others. Again, many of them were a low to moderate loss, and then there were those outliers further to the left. Lastly, I wanted to just show this application. This was earliest on. I'm going kind of reverse order here. From August 14th to the 20th. What gave rise to some of these fires last year in Pacific Northwest was a lightning event that was on roughly the 9th of August through the 12th. And you can see in the lower left image, the green is the Rogue River Siskiyou, and the blue is the Umpqua National Forest, and then the brown is the Willamette. And you can see the 200 plus strikes that were received. And so at the time, you know, we saw that we received this lightning. We started getting the fire reports, and there was a lot of questions about how do we prioritize all these fires? How does the forest prioritize the fires? How does the GAC prioritize these fires? So this is roughly 65 fires simulated, 4 different analysts, and then you can see the rest of the specifics there. So, you know, if you look down in the lower right for the key, the chutes in the Ochoco National Forest had 2 fires, and over the next 7 days, based on what they were burning in and the FS Pro runs, it would indicate that would actually be there would be a benefit to the fires burning in that area. RSF is the Rogue River Siskiyou, and they had 10 fires to the north, and then they had 10 fires to the south. So we grouped these, the Umpqua same way, north and south, and the Willamette north and south. And so if you're looking at this exceedance probability curve, you would say, all right, if we were strictly looking, if we were utilizing these EP curves to inform the prioritization, the fires on the chutes in Ochoco look pretty promising the next 7 days. And then the one that would realize a low loss would be the Rogue River Siskiyou and those 10 fires. And then, you know, about double the loss could be expected from the next group on the Umpqua and the Rogue and on the Willamette. And then the 2 that this would indicate are could be the highest priorities for the next 7 days would be the South Willamette and the North Umpqua. So I wanted to just take a minute and talk about some of the limitations. You know, it seems like so many things that at least I work on, we are developing them as we're using them, and that's exciting. So here are some of the things that I learned from this first season of doing this. You know, we're extremely dependent on high quality FS Pro runs. The output is only as good as the FS Pro runs, and the FS Pro runs are only as good as the expertise of the analysts. So you need to make sure you have the right people doing the runs that are familiar with the fire, and so that's why I really like to tap into those folks that had been on the fire a while and had been doing runs and really had them dialed in. The second thing to always keep in mind, though, is, you know, this is a very dynamic environment, and sometimes we just miss things. And you know, I've always smiled that we're pretty used to the weather forecasts missing things, but when it comes to the modeling and GIS and putting lines on the map, there seems to be a bit of a higher standard, yet we utilize much of what the Weather Service gives us. So there's a bit of a dichotomy there, but it's important that folks know that, you know, this is our best efforts, but it's with such a dynamic environment, you know, things contain like a plume-dominated fire. The timing consistency with the analysis is important. You gotta make sure that you have all your ducks in a row. The load on the WIFTIS system is something that was very real, and we definitely had issues with that last year. The time commitment to produce this, when we were first developing it was pretty clunky because we were just trying to develop the code to make these curves, but we got better at it with time, and we could produce them within a day or a day and a half. But it does take time to put all these things together, so you need to coordinate this. Also, the EP curves are a bit esoteric. So, you know, I've been working with Joe Scott to try to refine this process to make it quicker and to be able to display it in ways that maybe are more consumable. And then a couple last points. You know, I really want to be able to see into these curves, if you will, like that Horse Prairie curve that was definitely had a much higher loss, you know, on a magnitude of 5 to 10 times some of the other fires. You know, if that then asks the question, what is it? We may be thinking it's
WUI and it might be timber values, but maybe it's something different. Maybe there's a wildlife value in there that is significant. So I think if we could look into those curves of the why they are where they are, that would be helpful. And then lastly, I like this because it allows you to start using your risk assessment, but sometimes in doing so, you will find things that you like about your risk assessment and some things you're not too excited about and you need to change. This risk assessment for Oregon and Washington last year, we went through 2 versions based on stuff that we were finding as we were utilizing it on fires. So that's all that I have prepared and open to questions.
Thank you, Rick. Let's see, what do we have? How are we doing, Morgan? Do we have questions coming in for Rick at all?
There are none yet in the chat box, and thank you to the previous panelists who've been answering them directly in the question box. I have been also entering them in the chat so that everyone can see the questions that were asked and the answers. Okay, we do have a question, Rick, from Trevor Miller. He says, what can be done at the local unit level to have a leg up if and when EP curves are needed?
You know, these are highly dependent on the risk assessment, right? So we at the local level, if we want to, so I'll give you an example. Region 9 is interested in doing this kind of thing. Their MAC has been utilizing what they've done in the past, and they have L10s that come in and talk about the modeling, but they don't have a quantitative metric that's utilized to help with their prioritization. So, but to do that, we have got to create the asset CNBC layer for those areas, or else you're not able to do this. So local units would have to say, hey, we want to develop this information so that we can utilize it in this kind of fashion. But that, you know, that's a pretty heavy load, but it's doable. You know, we're starting to see these risk assessments in many different areas, and maybe with time we might even start seeing it on an, you know, on a maybe a national basis, or the Western U.S. on a cycle, something similar to like land fire, where this kind of thing with time can be more commonplace. Right now, it's still kind of a little more proof of concept or beta.